Have you ever stopped to think about how anything in the cloud actually talks to each other? Well, every single device needs a unique address, kind of like a house on a street. Today, we're going to become the architects of those digital streets. We're diving deep into IP addressing and, you'll see, the magic of CIDR. Okay, so here's our game plan. We're going to start with the basics in the cloud's address book, just to get our bearings. Then, we'll meet the 4 different faces of IP. After that, we'll get into the fun stuff, how we slice up the network pie efficiently. We'll even do a little math. Don't worry, it's easy. And then we'll wrap it all up with some real-world best practices you can start using right away. So first things first, the cloud's address book. Before we can build anything cool, we have to ask a really basic question. What's the fundamental language that every single device on the internet uses to communicate? At its heart, an IP address is really just that, a unique label. Think of it like a phone number for your technology. For one of your virtual machines to talk to a database, or for your own phone to connect to a website, they need these numbers to find each other. This is the absolute bedrock of all network communication. It all starts here. Now, okay, this is where it gets a little more interesting. You see, not all IP addresses are the same. They're not all created equal. Depending on what you're trying to do, you're going to need a different type. So let's explore the 4 essential phases of IP. First up, we've got static versus dynamic. A static IP is like your permanent home address. It's fixed, it's reliable, and it's absolutely perfect for your critical infrastructure. You know, your main application server or a VPN gateway that can't ever move. A dynamic IP, on the other hand, that's more like a temporary hotel room number. It gets assigned automatically, and it can change, which is totally fine for your laptop or some short-lived virtual machine. Next up, private versus public. And this distinction, well, it's all about who you're talking to. Private IPs are for internal chatter. They connect your apps and databases securely inside your cloud network, completely hidden from the public internet. But the moment you need to talk to the whole world, like, say, hosting a website or an API, you absolutely need a public IP. That's your front door to the internet. Okay, so we've got all these devices, and they all need addresses. This leads to a massive challenge. How in the world do we manage a limited supply of IPs for a planet with literally billions of connected devices? It's time to talk about how we divide up the network. No, seriously, just think about that for a second. Billions of devices online, from massive web servers to your smartwatch. How do we give every single one a unique address without just running out? The old systems, they just weren't built for this kind of scale. We desperately needed a smarter, more flexible solution. And that solution is CIDR. CIDR is pretty much the hero of our story. It lets us stop handing out these clunky, fixed-size blocks of addresses. Instead, it lets us carve out perfectly sized pieces of the pie. You need a small network for just a handful of devices? Great! Or a huge one for thousands? CIDR lets you create exactly what you need with basically no waste. All right, so we've covered the why, we get it. Now let's get into the how. It's time to look at CIDR by the numbers and see how all this theory actually turns into practical math that you can use. Everything in IPv4 addressing, and I mean everything, it all comes down to this number, 32. Every single address is just a 32-bit number. The real genius of CIDR is in how it lets us split these 32 bits. Part of the address defines the network, and the other part defines the host, the actual device on that network. And that little slash notation you always see, that just tells us exactly where that split happens. And this table right here, this makes it all click. Take a look at that first row, a /24. That's a classic. It gives you 256 addresses, which is perfect for a small, simple network. But what if you only need, say, 60 devices? Well, you can use a /26 to create a much tighter, more efficient subnet. Now, look at the power of going the other way. A tiny change to a /22 suddenly gives you over 1,000 addresses. That's the power of CIDR right there, total flexibility. And this is where it gets really cool. That /22 block isn't just some random number. It's actually 4 of those smaller /24 blocks all bundled together. This allows for incredibly efficient routing across the internet. Think of it like this. A mail carrier doesn't need to know the address of every single house in a city, right? They just need to deliver mail to the right neighborhood. That's what CIDR does for internet traffic. It groups addresses together for way faster, way smarter routing. So we've got the theory and the math down. Now for what I think is the most important part, applying all this knowledge. Let's talk about some real-world best practices for managing IPs in the cloud. Okay, Here's a pro tip that every cloud architect learns, sometimes the hard way. When you create a subnet, you don't actually get to use all of the addresses. The cloud providers, AWS, Azure, Google, all of them, they reserve a few for their own essential functions, like the network address and their internal router. This means your usable IP count is always a little less than the total. Factoring this in from the very beginning is absolutely crucial for accurate planning. So let's put it all together. Just think of this as your checklist for success. The key rules to avoid some really common headaches. Lock down your critical servers with static IPs. Plan your address space like an architect, always thinking about future growth. And please, please, minimize your public footprint to tighten security. Use things like private links and NAT gateways. Following these simple rules will save you a world of pain down the road. I promise.
And that brings us to the end. Understanding CIDR and all these different IP types isn't just some abstract knowledge. It's literally the blueprint for building secure, scalable, and efficient networks in the cloud. You now know the rules of the road. So the only question left is, how are you going to architect your network?